begin. So we're going to work with the same problem. We have our block and pulley system, and we have block A on an inclined plane of 45 degrees, and we have block B on an inclined plane of 30 degrees, and we're given that the mass of block A equals the mass of block B equals 50 pounds. I'm sorry, that's not the mass, that's going to be the weight. It's going to be the weight. And we're given that the initial velocity is going to be 0 because the blocks are initially at rest. And so we need to find the velocity, I'm going to call it the final velocity of the blocks when the blocks move, change in x, when they move 1 foot. And so I'll let you see that. So the method that we're going to use, this is a work and energy problem. Work and energy. And the method that we're going to use is kind of, I guess I'd say it's the pure work and energy form. And like previously we used Newton's second law, and this we're just going to cut straight into the equation that you see in the book. And so the relationships that we're going to work with are, we're going to get a relationship from block A, which is going to be 1/2 the mass of block A plus the work done from position 1 to position 2 equals 1/2 the mass of block A times, sorry about that, we're going to have equation number 1 for block A. It's going to be 1/2 the mass of block A times the velocity times the initial velocity squared plus the work from position 1 to position 2, or initial position to final position, and that's going to equal 1/2 the mass of block A times the final velocity squared. And then our second equation is going to be from block B, and that's going to say that 1/2 the mass of block B times the initial velocity of block B squared plus the work from position 1 to position 2 equals 1/2 the mass of block B times the final velocity of block B. Might as well put all this in. Final velocity block A, final velocity block A, or initial velocity block A, initial velocity block A. And then our third relationship is going to be from the cable. We're going to see that the final velocity of block A equals the final velocity of block B equals the final velocity. Just for clarification, because of the cable relationship, the velocity of block A is always equal to the velocity of block B, because if A moves, then B moves an equal amount. The cable doesn't stretch, and the pulley doesn't have any friction or anything like that. And so we need to draw a free body of block A. And so how we're going to do that, I like to just draw the inclined plane at 45 degrees. And then I like to draw my normal normal to black A, and my weight. Well, I'll continue through with the normal with the dotted line because that's going to designate my y-axis, and then the weight is going to come straight down the weight of black A, and it's going to be 45 degrees from the y-axis. If you set up your axis the way that I did, this is your x-axis, and then I'm sorry, we do have friction. We're given u sub k equals 0.05. So when our block moves down, friction is going to be against motion, and we're also going to have tension due to the cable in our x direction. And so, and then whatever the, since we're concerned about motion in the x direction, since we've designated this as the x direction, then in order to solve for work, we need to see how far it's going to change in the x direction. So we're going to sum up all the forces in the x direction. We're going to times it by the change in position, and that's going to equal our work. And so we have our tension plus our friction in the x direction minus the weight in the x direction times our change in position equals work. A simpler way to write work is work equals force times distance. And right here we have the sum of our forces times the change in position equals our work. So substituting values in, you solve for friction using mu sub k, and after you find your normal force, you solve for the weight in the x direction using your trigonometry. It's going to be this right here. And so it's going to be your weight times the sine of 45 degrees. And but I just don't have enough room to put that up. So after you solve for that, you substitute in your values, and you get your tension plus your friction, which is 1.77, minus your weight in the x direction, which comes out to 35.36, minus, or excuse me, times -1, because if the block is moving this direction, I assume that it's going to move this direction, and it's going to move 1 meter, so that's -1, the negative x direction here. And that's going to equal my work. And so now that I have my work, I can take this, and this is the work from position 1 to position 2. I can substitute it into this equation here, and I'm going to get 1/2 mass of black A times the initial velocity squared. That's 0 because the initial velocity is 0. So all I'm going to be left with is work equals 1/2 mv squared. So the work done is going to be T plus 1. Well, I have to times everything by -1, so it's going to be -T plus 1.77 minus 1.77 plus 35.36 equals 1/2, and we have our mass as 1.55 slugs times our final velocity squared. So we have two unknowns. We have our t and our final velocity. That means we're going to need another equation to be able to solve for that, and we're going to get our other equation from block B, and I'll draw that up tomorrow.